Welcome back to this session on knowledge application where we were looking at regression, linear regression. We found a significant regression for both the slope and the intercept and an R-square of 33.2%. So we're going to take the model, simply copy that. We're going over to Excel and we're going to paste that right in. Then what we're going to do is set ourselves up here for a prediction equation. We're going to put in the CTQ, and we put in the intercept, and the slope, and we put in the value of G. Now we're going to do some formatting here. Put it in bold, increase our font size a little bit here so it stands out real nice for you. There we go. We're going to increase our column widths here. Hey, there we go. Let's center this. We'll take this one, put it over here. So the CTQ, the intercept, here is given as minus 499.5. The slope, of course, is a positive 19.56. And we have a value of G. Now recall that we started with G at a nominal level of 50. So that's what we're going to use for right now. Put in the nominal level of 50. And then we're going to write the equation for the CTQ equals the intercept here plus this quantity of 19.56 times the value of G. And our predicted CTQ value is 478.5. Remember now, our target for that CTQ was 825. Now we could sit here and play around with G till we happen to hit on the right value, predicting 967, or we could algebraically take this equation and solve for G. In this case, we're not going to do that. We're just wanting to instructionally illustrate what's going on. We'll set that at about 65. Looks like about 70. So we'll modify that to be 70. Puts us pretty close to the target. So let's go run it and try it. We go over here to our simulator. We'll put 70 in, and we'll run 30 samples to see what we get. Take 30 samples. It's happily creating those. And we'll just quickly compute the average here to see if we were close to that. Put in equals average for those 30. And we got 607, and our regression model forecast 869. Well, you can see that was off with a G of 70. That will make for some interesting discussion. Remember, several things are at play here. There were a lot of other variables there. Only 33% of that variation was explained by G. So maybe we should have put more terms into the regression equation. That might have been one way to do it. Then again, maybe interactions are masking it, thereby creating a model that's not quite given the right results here. Nonetheless, we can see that we improved. We came closer to the target of 825. But these are some of the things to contemplate when you're using regression. We've got to be careful because what we just did here, when you go to do that in practice, can sometimes lead to misleading results because of interactions, nonlinearities in the other dependent variables, and a host of other things. But nonetheless, this is how we'd go about applying regression. Thank you.